Hello and welcome to SAT Prep lesson video number 13 on geometry involving area and volume. So this video is really just a bunch of examples. We don't really have vocabulary to go over besides what we see within our examples here. So let's take a look at some practice problems. In the figure, ABCD is a square, so we know that this larger shape here is a square, ABCD. Right, so this outside part, I'm going to go and highlight this. Okay. This is a square, okay, and we know that the side lengths are 2, so this side length is 2. I'm going to go ahead and zoom in a little bit to help us out a little more. Also, we know that E and F are midpoints, so that means that this segment and this segment and this segment and this segment are the same because these are midpoints. Okay, so this is going to be a 1, a 1, a 1. These are all 1s. That's also going to be a 1 because we know the whole side AD is 2, and if we're bisecting it with a midpoint, we have both of them being 1 and 1. We want to find the area of the quadrilateral, so we're trying to find this area right here, basically the shaded region, okay, the area of this quadrilateral. We're trying to find this area. Okay, well, not too bad of a calculation if you view it as some different shapes. If we take the square, so you've got this large outside shape, right? You've got this square here. So if we do a square, and if we go ahead and subtract these little triangles here, this triangle here, and this triangle here, okay, then we can get that quadrilateral. So this triangle kind of looks like this. You've got a 1 and a 2, right? And this is your 90 right here. This triangle is the same triangle. Okay, so really, this triangle is there and there. We have 2 of those. Okay, so we're going to subtract 2 triangles. So if we do the square minus those 2 triangles, we're going to get that green shaded region, that quadrilateral. So the square, we know, is going to be base times height, or side squared. Triangles, the area is 1/2 base times the height. Okay, so that's going to give us 4 because the side is 2 minus 2 times, and then if you look at your triangle, your base and your height are 1 and 2. The triangles, not the square, those little triangles. So 1/2 times 1 times 2, and you're going to get your answer of 2. Okay, and if we bubble that in, we can just put a 2 on the end and bubble that thing in there. Okay, so big shape minus a couple little shapes gives us that shaded region in between. Number 2, a right circular cylinder has a height of 12, so we know that the height, this right here, is 12, and a radius of 3, so this is going to be 3. X and Y are points on the surface of the cylinder. What is the maximum possible length of X, Y? Well, the furthest apart they could be is this diagonal right here, right? Because they're giving us this point X and this point Y. So you have to imagine that diagonal is going through the cylinder from this top left corner to the bottom right corner. And try to imagine you actually could draw in a right triangle. It would kind of be like on an angle through that shape, but you have a right triangle, okay? And what do you know? Well, we know that the height right here is 12, right? Because that height carries over throughout the entire cylinder. So I'm going to go ahead and zoom in a little bit here. So this height is 12. And then we also know that the radius is 3, so that means that this part is 3, which means the whole thing across is going to be 6. Okay, that diameter is the base of your triangle, okay? And you're trying to find the maximum, or that distance between those two, this distance right here. Okay, that's going to be this right there. Trying to find that hypotenuse. So we're going to use Pythagorean Theorem. So we're going to use the good old Pythagorean Theorem where we have a squared plus b squared equals c squared. Okay, in this case, c is my hypotenuse, I'm calling it d. So that would be 6 squared plus 12 squared equals, let's go d squared. And do a little bit of work here, you're going to end up with 180 equals that diagonal squared. So the diagonal is square root of 180, which if we reduce is going to be square root of 36 times 5, or if we kind of factor that out. So that's going to be 6 root 5. All right, so that's our answer, 6 root 5. Hopefully it's one of them, and there you go. It is letter C. Okay. Number 3, we want to find, let's see here, we've got an arc, which is a quarter circle. Okay. So PQR, so this right here is a quarter circle at PQR right there. The radius is 6. They tell us that right there. And the quadrilateral, OSQT is a rectangle. Okay. What is the perimeter of the shaded region? So here we go. Let's take a look at what's happening here. So here's what we have. We know. Let's handle this part first. Okay. The arc. This arc is a quarter circle. So if we're trying to find the perimeter of the shaded region, we have to calculate this arc because that arc is part of the perimeter, right? So we know that we're going to have 1/4, because it's a quarter circle, right? 1/4 of a circle, so of the circumference. Remember, the circumference of a circle is basically perimeter. Okay, this is essentially perimeter of a circle, is what circumference represents. We know that circumference is 2 pi r, so we're going to have 1/4 of 2 pi r. Okay, so that's just the blue part. But then we have to calculate, okay, what is, this part here? What is this part here? What is that part there? What is this part here? Let me color coordinate this, even make it even more clear for you. If I just color coordinate the vertical pieces, the vertical components, the 2 green lines, right? Those 2 green lines, let's call that, plus my vertical components there. Well, we know that those 2 green lines add up to 6, right? Because it's the whole height or the whole radius. Okay, so they're going to add up to 6. And then look at the red ones. Well, if I'm going this way and I'm going more that way, if I add those 2 red lines, imagine that this one comes down here because it's a rectangle. It basically takes up this space right here, right? So that means that this is going to be my horizontal component, and that's going to also be 6. Can I even put an arrow like this comes over here? It's the same size. So we know the radius is going to be 6 also, so they told us that. So let's calculate. Sorry, this is supposed to be 1/4. Made a mistake there. So 1/4, 2 pi times 6 plus 12, because you add those 2 together. This is going to give us 12 times 1/4. That's 3 pi plus 12. So our answer is letter B. Okay. Number 4, find the volume of the solid. The figure is not drawn to scale. So we know that for a cylinder. Okay, so volume of a cylinder, it's going to be pi r squared h. Okay, it's the area of the base times the height. This is going to be in your booklet, just so you're aware, on the SAT. They give you this formula for a cylinder. Obviously, you have to know it's a cylinder, but they give you that formula, pi r squared h. Okay, now, the issue is, look how much is missing. Okay, so we've removed 1/20 out of 360. Remember, all the way around is 360. Okay, so that's how much we've removed. So we have remaining, so from our full cylinder, we've removed that amount, which is essentially 1/3. So we have a remaining of 2/3. So we have 2/3 of a full cylinder. So if we want the volume, we're going to actually have to multiply by 2/3 because we don't have a full cylinder left. Okay, and the radius, you can see right here, is 6. So 6 squared, and the height is 8. Okay, so if we go ahead and multiply that out, we're going to get 192 pi. Now you can't put the pi in your calculator, because if you put the pi in your calculator, it's going to give you a decimal. But you could, multiply everything else out, maybe without that calculator, and then you'll be good to go. Okay, so that's how I can calculate that shape. Again, it's because we've kind of taken a chunk out. You've taken out 1/3 of the cylinder, so we have 2/3 left. Okay. Question number 5. In the figure, the cube is divided into 27 smaller cubes of equal volume. If 12 of these smaller cubes have a combined volume of 36 cubic units, what is the volume of the entire thing? Well, let's use a ratio. Okay, so we have 27 smaller cubes. So x over 27. Okay, and from there, what else can we figure out as far as a ratio? 12 of the smaller cubes has a volume of 36. Okay, so my x is my volume. My 27 is the number of cubes. Let's clarify this. This is your volume. This is number of cubes. So we have to keep our ratio in that same setup. So I have to go volume on top, which is 36, and my number of cubes in this case is 12. There's 12 here. Okay, so once you have that set up, you just cross multiply and you're really good to go. So 12x equals 27 times 36. You can divide the 12 over, so you're going to x equals 81. All right, and then you're good to go. So you'll see this. The shape itself, the visual, doesn't help us in any way solve the problem. It's more about ratios and proportions in this case. Okay, why don't you take a second, try this one yourself. Try number 6. So pause the video, give number 6 a shot, and then when you're ready, restart the video and we will go over it. Okay, so here's our scenario. It says a student walks x kilometers along a straight line from P to Q. So from P to Q, from here to here, this is x. Okay, then they walk on a straight line from Q to R, and that's y. And they want us to figure out what is x plus y. That's the question. Okay, well, we have a scale. So we know that 2 spaces is 1 kilometer. So if we're going, here's 2 here, and here's another 2 here, right? So that's going to be 4 total. And then this one, if we're going 2 here, and we're going 2 here, and we're going 2 here. Oops, sorry, I meant to put 1s for those, my bad. Hang on. 2 spaces, but it's 1 kilometer. So this is a 1, this is a 1, so that's 2 total. And then we're going 2 spaces, so that's a 1. Another 2 spaces, so that's a 1. And another 2 spaces, so that's a 1. Okay, and then we've got 1 space. Well, if 2 spaces is 1 kilometer, then 1 space is a half kilometer. So this is going to be 3.5. So we have 2.5, or 2, sorry, plus 3.5 gives us 5.5. Pretty straightforward, right? But you got to use that scale to help you kind of figure out that calculation. And you're not going on an angle here. You're not going directly from P to R. You have to go from P to Q and then Q to R. So be very careful how you read that question. The shortest distance would be from going from P directly to R. That's not what the question is being asked of us. So we go ahead and zoom in a little more on this guy just to kind of see the diagram and everything. So it says that Corey, a packaging engineer, is designing a container to hold 12 drinking glasses shaped as regular octagonal prisms. Her sketch of the container is shown here. If the length and width of the container are doubled, how many more glasses could the container hold? So think about this in terms of, I know there's numbers like 12 and 9, but really you should think about the length and the width in terms of number of glasses. So you see how there's 1, 2, 3, 4. So this has a width of 4. Let's call it 4 glasses. And then over here, this width is 1, 2, 3 glasses. Okay, so your length is 4, your width is 3. So original length is, let's say, 4 glasses. We're going to use it in terms of glasses, not in terms of the actual inches. And width is 3 glasses. So now if we double that, so let's double. Okay, and we're going to get what by what? We're going to get 8 by 6. Right, so you'd have 8 glasses. I'm not going to draw them all, but you'd have 8 glasses by 6 glasses. So how many glasses total is that? That is 48 glasses. Okay, because it's talking about glasses. We don't care about the dimensions really as far as inches. We want to know the number of glasses. And over here, this one has 4 by 3. That's 12 glasses. And it says how many more glasses? So 48 minus 12 gives us 36 glasses. That would be our answer for this one. Okay, so you would go to your little grid in. Oops, I mean to move that. Go to your grid in. You would grid in 30, 36. So 3 and then 6. Okay, you can put at the front too if you want to, but then don't put zeros afterwards. We usually just put them on the end just to clarify and make sure you don't add random zeros and make a mistake. All right. Okay, so this one, our last question, says that the figure above is the floor plan drawn by an architect for a small concert hall. So this is like a two-dimensional drawing if you're looking down at the floor, maybe like up from the ceiling, okay? And the stage has depth 8, so you can see your stage. This height right here is 8, this depth. The two walls have length 10. Now, use this. If this is 10 and this is 10, that's an isosceles triangle. So what that means is this height, this 8, would divide this side into two equal pieces. It's a property of geometry, okay? So we know that whatever these dimensions are, and we can figure that out hopefully, these are going to be the same values. I'm trying to get these marks to look decent. Okay, so from here to here and from there to there. All right, we know that the seating portion is 180 square meters. Okay, we're trying to find the value of x. So how are we going to do that? Well, we can find x if we could figure out this whole side. That's the key. If we know that whole side, we can do this, right? X, let's call this y over here. X times y equals 180. Okay, so let's figure out what y is. How in the world are we going to do that? Well, you'll notice if I take this little right triangle right here, this guy, okay, this is a right triangle. This is a Pythagorean triple. Pythagorean triple. And if you don't recognize it, you can use Pythagorean theorem, but it's a 6, 8, 10 triple, which means that this is also 6 over here. So our y is 12. All right, so now that we got that, we've got 12x equals 180. So x equals 15. So there we go, got our answer. So 1, 5, bubble, and bubble. All right, that's it for this video. Thank you very much for watching. And as always, please make sure if you have questions, want to go over anything, come on into our SAT prep sections to our Zooms, and we'd be happy to help you guys. All right, have a good one.